Well, we've seen what happens when lengths are proportional. We've got these similar figures. But what about the area or the volume of similar figures? In this video, we're going to learn how the scale factor of the lengths compares with the scale factor of areas and volumes. And here's a quick example before we do the actual problem on the paper. Let's say, for example, that the length scale factor was 2 to 5, 2/5. We could use this to see how the area of the two shapes would compare. The scale factor will not be 2/5. As you can see indicated by my little symbols here, you have to take the length scale factor and square it. So the area scale factor would be 4/25. This is how the areas would compare to each other of the two shapes. And volume, again, has to be compared back to the original scale factor. And the volume is going to be the cube of the length scale factor. So 2 to the third power is 8, and 5 to the third power is 125. And sometimes we have to work backwards. Say if they gave us that the ratio of areas was 9/49, and we need to find missing volume, so we need to know the ratio of volumes. Well, everything stems from the length scale factor. So we sort of have to look backwards and ask ourselves, okay, we know that to get the area scale factor, we squared the length scale factor. So, what length would square and give you 9? Well, that would be 3. What about the 49? That would come from 7. So, or you could think of it as taking the square root of 9 and the square root of 49 and getting 3/7. Alright, at any rate, once you have the ratio of the lengths, in this case 3 to 7, then you can go ahead and find the volume scale factor by cubing this. 3 to the third power is 27, and 7 to the third power is 343. Whoops. Okay, so that's the type of thing we have to deal with right now. So the ratio of two sides of similar cubes is 3 to 4. So this is going to be relatively simple because they are just giving us the length scale factor, which is 3 to 4. Alright, the smaller cube has a volume of 729. What is the volume of the larger cube? Well, as we discussed on the black screen, if I have the length scale factor, I have to cube it to get the volume scale factor. So that's what I'm going to do. So if I want the volume scale factor, I've got to take this and I've got to cube it. 3 to the third power is 27. 4 to the third power is 64. Okay, so I'm going to use this scale factor and set up a volume proportion. Alright, this is small over big. So when they say the smaller cube has a volume of 729, okay, so we're going small over big. So the 729 is going to go here. And they want to know what is the volume of the larger cube. Well, that'll go here, small over big. So it's just a matter of cross multiplying here. So 27 times x will just be 27x, and 64 times 729 That's 46,656. Which needs to be now divided by 27. So that's 1,728. Okay, we're doing units, cubic meters. Let me stick that on there. Alright, so that is how you can find scale factors of volume, and we looked at area, if we know the length scale factor. That's it for this video. That's all I wanted to show you in this video. I hope it was helpful, and I will see you on the next video.